Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the inserting a node into a sorted doubly linked list. And for this particular challenge, it says given a reference to the head of doubly linked list and an integer which is data parameter, create a new doubly linked list node object having data value of the data and insert it at the proper location to maintain the sort. And for this example, we have the head parameter that refers to the list of 1, 2, 4, and then null. And if you notice, we have double arrows that pointing back and forth, which a notation of the doubly linked list. If you notice, the singly linked list is only points from node 1 to the node 2 and not the other way around. But for the doubly linked list, we have the class of the doubly linked list node, which is the value of integer data that the value inside the node as the data property, and then the doubly linked list node of the next property which points out to the next node, which is 2 on the right arrow side notation, and also for the previous property that takes null because one does not contain any previous node. And for the node 2 we have the previous property that takes another doubly linked list node called node 1 and the next property which is the node 4. Let me draw this out. We have node 1 like this, and then node 1 is, let me visualize this. We have the previous property of null, and then the node itself which is node 1, and the next property is node 2. The right arrow sign is next property and the previous arrow sign is the previous property. And for the node 2 we have the previous property of 1 points to the previous using the left arrow sign, and the node itself which is the data property of 2, and the next property which is 4. And if you want to align this is the rough visualization of the doubly linked list. Let me eliminate this part and also eliminate this part, so it is the same node, 2 and 1, the same node. If you want to merge the visualization, it will be a left and right arrow sign. Okay, so for the data is 3 that we need to solve. We have the function public static. The data type of the returning is vector returning from the function called the doubly linked list node, and the function itself is called the sorted insert that takes two parameters. The first one which is in a form of doubly linked list node called the list, and the integer of the data. The integer data, which is the 3 right here, we need to insert 3 between the chain or on the front if it is lower than the 1, or at the back of the chain if it is higher than 4. If it is 3, since it is 3, then it will be inserted, it will try to insert between the 2 and 4. So in other words, we are trying to rechain, create another node called the 3, and then we need to rechain the 3 node, insert it or append it between the node 2 and node 4. And then after we disassemble the node 2 and node 4 chain, we need to reassemble it back using the 2 next property which points out to the 3 node, and also the previous property of node 4 will points out to the node 3, and the node 3 should be points to the previous node of 2 and the next node of 4. If we happen to insert the node 3 into our node chain, list chain, we have the 1, and the next one we have the 2, and then the next one is points to the 3, and the next one should be points to the 4, and the 3 right here will points to the previous, to the node 2 and the next node which is 4. And also the thing is, we need to also assign the 2 dot next which points to the 3 node, or the node 3, it's the new one, using node 2 chain, and the node 2 will chain to the 3, and also the node 4 chain using the previous property, and this is node 4. We have node 4, we need to reassign the previous property. Instead of using the 2 as the node, then we reassign this to the node 3. And so that creates a new chain of the L list without breaking the initial structure of the L list. We are going to use a pointer for this challenge. And for the function description, it says complete the sort insert function in the editor below. We have two parameters like I described earlier. And so one thing, if you want to use something else other than Java 7, then go ahead. I encourage you to do so, but for this challenge I'm going to use the Java 7 for this challenge. Okay, so the first thing is creating a new node called the Doubly linked list node, called the new node that constructs new Doubly linked list node that takes the data. Since the new node will have the data of 3, then we need to assign the data as the parameter that passing from the integer data parameter right here. And that way we are creating node 3 just in case if we happen to insert node 3 before or after the existing chain of the node. To visualize this, the node data will take property of null of the previous property, and this is the node itself, contains the data property of 3, and the next property will be null. That is the constructor builds from the Doubly linked list node of the new node. Okay, so for an edge case check, we need to check if the L list or the L list parameter is null. If it is null, then we need to return the new node as our answer. Why to check if L list is null? L list is already null, is just null value without any previous or node or the next property, so it's just null as it is. Then we need to return the new node instead, just in case if the L list parameter is already null. If it's not, then we can add a check, another check, if the data is lower than the L list dot data. Why using the check right here? The data is below the L list data. This check is for check if the data parameter is lower than the L list dot data, which is L list is always points out to the head of the list, which is data of 1. So if we have the L list data of 1, we have the 1, and then the next property is 2, and the next property is 4. Then the L list dot data will always points to the data of the first node chain. This is the L list property or the L list variable, and this is the data. If the data is lower, let's say if it's 0 or -1, then we need to assign -1 using the previous of the L list. So in the previous, since it is already null, then we assign the data inserted into the previous property of the head chain using the new node dot next. Don't forget to use the next property dot next and assign the L list itself. That way we are assigning the let me copy this part, and we are assigning the next property, which is the right arrow sign. Instead of using null, then we assign this as the L list. We are assigning the L list, which is the property of 1, 2, and 4. That way we are assigning L list 1, 2, and 4, and then null. Don't forget the null, or just not placing it at all. It is the same thing. And the next one, we can change the L list previous, since we have previous property, assign this as the new node, and that way we have the L list right here. Let me copy this part, and the L list will be, instead of null, since we are using the previous property or the left arrow sign, then we are assigning the 3 into our answer, since if only the if check is satisfied, like using the -1 or the 0 or anything below the 1. We can also add a check using it. Instead of using the below, we can also use the below or equals. Why below or equals? It is the same thing. If you want to use 0, or if it happens to be also the data parameter, I'm sorry, it's also 1, then it is also the same thing, because the both nodes also points out to the same thing, and it is also still sorted, which is 1, 1, 2, and 4. What sorted means, it means from the lowest to the highest one. Since 1 is the same, then we don't have to worry about inserting the if else check with the below or equals. If it is 2, then this if check will not apply, and we move to the next edge case. If it is 2, null. If it is 2, then it will not apply. Then if it's 1, then it will apply to the if check right here, and then the 1 will be inserted into the answer. Let's say if it is 1, if data prime is 1. The same thing also goes to the 1 or below than 1. And then we can add another check if the data property, or not data property, but the data parameter right here. I kept saying the data property, if it's a parameter. Since it is 3, then we need to loop over the node chain from 1, 2, and then 4, and then how do we check if 3 is higher than 1, and then check if 3 is higher than 2? Since it is, then we need to check again if 3 is higher than 4. If it is not, then we need to assign 3 between the 2 and 4. How do we do that? We need to add a pointer using the Doubly linked list node called the pointer that takes the L list itself. The pointer variable acts as a pointer like this. Let's say if we have the L list pointer right here that points out to the null, and then 1, 2, and 4, and then null. The pointer will act as the pointer of the head I'm going to use the caret sign or caret notation to point the head of the current pointer, and then the pointer will move each loop or every iteration to find out if the data parameter is higher or not. Since 1 is lower than the data, then we need to move to check if 2 is lower than data. If it is, then we move again, check if 4 is lower than data. Since it is not, then we need to assign between them. For the next operation, assigning the 2 and detach the 4 from the node 2, and also detach 2 from the node 4. Then we can do the operation later on after the pointer checks out everything using the while loop. We can add check. The while loop will stop only either the dot next is equals to null, and if the current dot next dot data, which is the next data, is higher than the data itself. It is not a current, but it is a pointer. Why I am using the pointer dot next is not equals to null? We can add a check. Since the pointer is already pointing to the head right here, for the while loop will check if the pointer dot next, since the pointer points the next property of 2, since it is not null, then it will return true, or it will fulfills the while loop, the first statement. And for the second statement, which is using the n or the double ampersand signs, it points to the pointer dot next dot data to check if the data parameter is still lower than the actual data that we need to insert between them using the property of next. The while loop will look up for the pointer dot next, which is the node next itself, to check if it is null or not, and also to check if the data using the 2 as the data right here, pointer dot next dot data dot next is points to the node itself right here from the pointer right here, which is still right here, and the data property, which is 2, compares it against the 3. Since it is still fulfills the while loop check, then it will move the pointer to the next one using the pointer equals to the pointer dot next. That way we are moving the pointer to the next one if it satisfies both pointer dot next is not equals to null, that checks out, and also pointer dot next to data, which data of 2 is still lower than the data parameter of 3, then it will move right here. Pointer equals pointer.next. That way it moves the pointer right here. And we can add another check using still running the while loop. The next iteration, which is pointer.next, it is pointing to the node 4. It is still not null, and also it is not satisfies the pointer.next.data, which is 4 is higher than 3. Remember that the data 4 it is not satisfied because the check right here is equals to false because 4 is higher than 3. It should have been the other sign around, using the right hand side, not using the left chevron or the left angle brackets. Then the while loop will stops, and then the pointer is still pointing to the node 2 right here. And that way we can assign or chain the new node dot next, new node dot next using the current dot next or the pointer dot next. I'm sorry, I keep using the current. Why I'm using the new node dot next, assigning using the pointer dot next? It is confusing, I know. The new node dot next, we have the new node. Let me see for the new node. We have this one, new node dot next, which points out to the null right here. We are assigning the pointer dot next. The pointer dot next, we have the pointer of the state of 2. Remember, we still have the pointer of 2 that points out to the next property of 4. And that way we are assigning, let me copy this part and paste this one. And that way we are assigning the 2 dot next. Since the next property is 4, then we are assigning 4 as our variable of the or the property of the next property from the new node dot next. And that way we are assigning 4 as the next property. And then we can add check if, using if check to check if the node itself it can be chained back to the tree. Since we are working on the doubly linked list, then we need to check if the left arrow sign is applies or not, is suitable for the node 3 using the previous property. If the pointer dot next is not null, then we need to assign the pointer dot next dot previous of the new node. Why it has to be like this? It's because since we are working on the doubly linked list, this state is only points to the next node, which is not the other way around. What if the 4 is already null? It is just a safety check. If the, let's say if the 4 is already null, then we don't have to reassign the null dot previous because it is already null. It doesn't contain any of the previous property because the variable or the value is already null. Then the null will not have the previous property. Since it is 4, since it is the pointer dot next is not null, this is exists, then we need to assign the pointer dot next, which is pointer dot next. Pointer dot next is points to d4 and then points again to the previous property using the left arrow sign right here. Let me copy this part. Copy this part. This is the pointer dot next, which points out to the node 4, and using the dot previous, using the previous property, which points out to the left arrow sign that points out to the new node itself because of the doubly linked list. And the new node itself is 3. And that way we are chaining both. We are chaining both node 3 and node 4 all together. So that is called a doubly linked list between node 3 and node 4. And we have off to a good start right here. For the next check, we can chain the current pointer using the pointer dot next. Assign this with the new node. Why it has to be a new node is because the pointer dot next has the pointer dot next is points to the node 4 right here. This is the pointer. Remember, this one with the chevron sign is points out to the 2, and since we are working with the doubly linked list node, the next property is 4. And this is the previous property of the pointer dot next, and this is the next property of the pointer dot next. I'm sorry, it is not 4, but it is a 2. And that way we are assigning pointer dot next we have the pointer itself, which is 2, and the next property, which is the right hand arrow sign. This is the next property of the pointer, and then we assign this as the new node. That way we are assigning 3 of the node right here. Since the state before we have the 3 that already chained with the 4, then we are assigning the 3 and 4 all together because of the new node already mutated from the new node dot next using the pointer dot next, which is points to the node 4. And this part is the new node from the mutation before, from the new node dot next assigning with the pointer dot next, and then we need to chain it back using the new node dot previous, because we are working with doubly linked list again, using the previous that we assign the previous node of the 3 and 4. Let me use the 3 to minimize the confusion. This is the previous property that points out to the pointer, and that way we are assigning 2 as the pointer, not as the pointer but as the previous property of the new node, and that makes the 2 chain with the 3 and also change back to the 2 and also node 4 for the chain. And from this previous check, if else check, if check right here, since it is already mutating, then of course we are assigning this left hand side or left hand arrow sign to the previous node, which is node 3 from the previous node property of 4. And that way we can return the whole list instead of the current pointer. Why? Because current pointer is only pointing to the node 2 right here, which is the head of the node. And that way since the pointer already builds everything from the while loop, the if, and the everything else before the return statement, then of course we only return the list as a whole node chain. So let's run the code again to see if it works. And we have an error, illegal static declaration in inner class solution. Maybe it's because the static function of the sorted insert is placed inside of the class result. If you notice the curly brackets right here, we can place this outside of the result class. Let me move this out of the closing curly brackets, and we ultimately place the function of the sorted insert function outside of the result class. So let's run the code again to see if it works. And we have a wrong answer, and it should be 1, 2, 3 and 4 instead of the 2, 1, 3 and 4. What about checking this one? If the data is below the list.data, and let's run the code again to see if it works. It is still error. Let's undo this part. Oh, I forgot to return the pointer from the return after the first if check. If the data is lower than the list.data head, which is the list head of the data property, if it is lower than the node chain, then we need to insert the data at the front of the node chain and return the data with the new created chain of the from the existing list chain. We can simply return the new node chain, as simple as that. So let's run the code again to see if it works. Okay, so that's about it. I'm sorry that it took so long to solve this out. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. I hope you have a great day. Thank you for watching the video, and I will see you in the next video. Goodbye.